So, statistics is the gathering and interpretation of data. Now, if you went into statistics, you could make the big bucks because a lot of these big companies, they hire statisticians to come in and give them data analysis on their company. For example, Vivint is a multi-million, billion-dollar industry. It makes so much money. And so they hire statisticians, those owners, to do the data analysis for them. Okay, so first of all, the first thing we're going to talk about is 12-1, which first talks about measures of central tendency. I always have students say to me, what are measures of central tendency? Okay, think about it. It's what things tend to be in the center. Uh-oh, not writing. What things tend to be in the center. Does everybody see? So there are different ways of looking at the center of your data. Most common, people usually look at the center by average. So average is just mean. We're going to look at different measures of central tendency. We're going to look at mean, median, and mode. So everybody, how do we find mean, median, and mode? I'm going to remind you. So look up here. I have a data set. 1, 2, 3, 3, 4, 5, 5, 9. Let's say these are the ages of a bunch of cousins. Do you guys have cousins? These are the ages of a bunch of cousins. If I said to you, what's the average age of all your cousins? You would find average is the same thing as mean. So mean means average. So if I say to you, because in statistics, they don't say find the average, they say find the mean. Mean means average. How do I remember that? So it's the stupid trick. If I say to you, you're an average student, that's kind of mean to say. So that's how I remember it. So how do you find the mean? You would add up all of the points and then divide by the total number of points. So 1 plus 2 plus 3 plus 4 plus 5 plus 5 plus 9 divided by 8 data points is 4. So I'm going to highlight that, guys. 4 right here is the average. Now look, do you see how that is tending to the middle? It's not right dab center in the center. It's towards the center of the data though, right? Look at it. Yes. Okay. So that's a good way of looking at center of the data. Now median is a different center. Median is the true middle, just like on a road. A lot of times there are medians that separate the true middle of the road. This is what falls exactly in the middle. So to find median, you will have to put your values in order from least to greatest, and you will count in and see where is the middle. In 1, 2, in 1, 2, in 1, 2, in 1, 2. Uh-oh. Do you see how I ran out? It was between here. Does everybody see? I went in the same amount. In 1, 2, 3, 4. In 1, 2, 3, 4. Do you see how it's in here? So it's the middle of 3 and 4. How would we find the middle? Add them, divide by 2. So 3 plus 4 is 7 divided by 2 is 3.5. So our median, our middle of the data set is 3.5. Yeah, if there is two middle. Sometimes there's a true middle. Like it is one value. Does that make sense? So this one fell between 2. So we had to average them. Now mode is what happens most. It's most frequently occurring. So look at this data set. If I said to you, what's the mode of these cousins' ages? I'm saying, what's the most frequently? Yes. What's the most frequently occurring age? You would say, well, 3 happen. Yeah, we got it. So we would say 3 happens twice, correct? And 5 happens twice. So that means the mode, what happens most is ages 3 and 5. Does everybody understand? Now here's the thing. If there is more than 2 modes, it's the same thing as having no modes. Because if you have lots of modes, more than 2, it's just as equal as saying no mode. So let's say I put another 9 in here. My mode would be 3, 5, and 9. That's too many. Either 2, 1, or none. So we would say no mode. If I was to add in another 9, now do you see how there's 3 9-year-olds? Now they're the mode. Because that happens 3 times, and no other age happens 3 times. This is what happens most. Everybody good? More than 2 modes is no mode. Okay. Now that is the center of our data. So look, those are centers of our data. Another word is the word outlier. So an outlier is a value that is substantially larger or smaller than the rest of the data set. Now, here's why it's important to understand how outliers work and what happens. An outlier can really skew your data. Now, everybody look at these scores. I'm going to give you an example here. So an outlier is substantially larger or smaller than the rest of the data. So let's say that this is true. A teacher is going to lose their job if their students do not score an average of 80% on the end of level testing. So to make it easy, let's say this teacher only has 4 students, and here are their scores: 75, 90, 99, 20. So what would the outlier be? 20. This is substantially smaller than the rest of the scores. Well, it is what it is. So let's find the average here. Does the teacher get to keep their job? So what is the average? So you did this plus this plus this plus this divided by 4. They got 71%. So this teacher is then terminated. Well, let's hope that this teacher then says, can I see the data that you are terminating me based on? So they give this teacher these scores. Well, the teacher looks and says, oh, well, this was Johnny, and he literally came to school 30% of the year. 70% he was absent. Is it my fault he didn't learn the material? No, not really, and that's an outlier, so you know it's a fluke. It's an outlier. True? Isn't that the only student that scored that low? Is that really my average? In my opinion, as the teacher, I'm saying no. So let's get Johnny out of there. Let's find my true, better average, in my opinion. So my average, in my opinion, is 88%. Now, let's say you took it to court and provided them with that information. They would agree, you would get your job back. That is really not fair to lose your job over one student who never came to class. Does that make sense? So everybody, do you see how an outlier really skews your center? That pulls your center clear down lower. Does that make sense, everybody? So an outlier can skew your measures of central tendency. Now here's the thing, you would always, unless told otherwise, you would not choose, because you're not a statistician, you would never throw out an outlier unless told to do so. So if I said find the average, you would use the outliers, okay? Awesome, I'm just showing you how they affect the center of your data. Use it. Okay, do problems 1 and 2 by hand. Find the mean, median, and mode. Now remember, you do have to have them ordered in least to greatest. Mean, median, mode. Now on number 2, it says frequency. Think a little bit, you guys. What does frequency mean? How often, how frequent it happens. So if it says it has a frequency of 2, does not mean that that number happens twice. Okay, awesome. Do those and then we'll... So do 1 and 2 by hand only, and then you're also going to do 4 and 5. Now, everybody listen to this next part, right? Just a second ago, we were talking about mean, median, and mode. That was the center of the data, different types of centers. Now we're not talking about centers. We're talking about spread. How spread out is the data? Now, that would be, an example of that would be range. So a lot of times you'll see them say, find the mean, median, mode, and range. Range is really more talking about spread. So how you find the range is, what are these numbers ranging over? So how you would do it is you would take your largest value minus your smallest value, which is 10. Now it makes sense. Range is spread. If you start at 2 and end at 12, isn't this spread out over 10 units? Everybody understand what range is? What is this ranging between? 10 units. Okay, now, range is all good. Yeah, it talks about spread. It's spread out over 10 years. So if these were ages of siblings, let's say that you have a bunch of siblings, your parents have had a lot of kids here, there's their ages, they're ranging over 10 years. They've had all these kids over a 10-year period here. Does everybody see? Okay, so now, here's the thing though, let's pretend, so range is all fine and dandy, that is how you find range, but sometimes there can be some interesting kind of skewed ranges. Like let's say that there was a fluke and one of these parents started really early and they have a 20-year-old. And then they waited a few more years and then started having kids again. Okay, so what would the outlier be? 20. So if I said to you, what's the range of all your siblings? You'd say, well, we range over 18 years. True? But is that a really valid, really good range? Not necessarily, because there's a big gap, correct? So I'm going to pretend, okay, so an outlier might kind of skew your range. So let me show you why I'm telling you that. I'm pretending, we're going back to the normal data set. So watch what I'm going to do. If I said find the median age here, what would you do? Find the middle, correct? Let's find the middle. In 1, 2, in 1, 2, in 1, 2. Uh-oh, isn't it between these again? So you would do 5 plus 8 divided by 2. 6.5 is the true middle. Now look what that just did. That then split their ages into two groups, a lower group and an upper group. Now if I asked you to find the median of the lower half, the middle of the lower half, what age would that be? 3. What's the median of the upper half? 10. Now it might be more accurate to say the spread is better said as 10 minus 3, which is 7. They're really closer to spread out over 7 years. Does that make sense? So, I mean, that's what's called the interquartile range, what I just did. 10 minus 3 is what's called the interquartile range. So, right here is what they will call Q quartile 1. Our overall median is quartile 2, and the median of the upper half is quartile, my pen is having issues, quartile 3. Does everybody see? So to find interquartile range, they will kind of abbreviate it as IQR. The interquartile range is Q3 minus Q1. I would write that down. So our interquartile range for this would be 10 minus 3, which is 7. Now, I'm not asking you to be a statistician. I'm not going to say to you, find the range, and then you have to know if you should find the interquartile range. I'm literally going to ask on the test, find the range, find the interquartile range. Does that make sense? Okay, but I'm just trying to get you to see why this would be maybe more useful. If you have an outlier, the interquartile range better describes the spread. Okay, so how did I find this? I found Q2 was the overall median, Q1 was the median of the lower half, Q3 was the median of the upper half. Now, I could make you do that by hand, that wasn't that hard. However, our calculator will do it for us. Hey, if I asked you to find the mean, median, mode range, interquartile range, I have confidence you could not do it by hand. However, let's just use our calculator. Yeah, that's why now I am showing you how to use your calculator. So here we go. Pull up your calculator, everybody. Go to problem 8 on the worksheet. Now, this is statistics, so I'm now going to teach you how to just do it in your calculator. So it makes sense that we're going to hit the stat key. Hit stat. Then go into edit. We need to give our calculator the data set. So in list 1, type in number 8's data. 2, hit enter. 8, hit enter. 3, 7, go. Enter the data set. 3. Next thing is, what you're going to do is you're going to type in, hit stat again, hit stat again, hit stat again, and go over to calculate. We will be in this class always just putting in one data set. So it's a one variable statistics at this level of statistics. Okay, one variable statistics. Hit enter if it asks you some extra stuff. Until you see this screen. Now it's going to give us a lot of extra information, so I've got to show you what is important to us. Now, X bar is actually the way of writing average or mean. So you'll just have to remember that X bar is another way of saying mean. Write yourself a little note. X bar is also the same thing as mean. So our mean, or average of the data set is 12.5. True?
Yes.
Okay. Now you're going to ignore, you're looking back up here, ignore the sum. We're not doing sum stuff. Ignore the sum squared. Ignore S of X, ignore this sigma. N equals 26, that's the number of terms you put in. Now look, scroll down. What is the minimum value? 2, nice. And there's quartile 1. There's our median. Isn't median middle? Yeah, then look, there's Q3. You don't even have to do it by hand. And then there's our maximum. So what is the median? Tell me again. 10.5. We know our middle is 10.5. Now, mode is not able to be found in the calculator. You have to look with your eyeballs and see. So looking at that, now here's why the calculator is nice. We didn't have to put it in order. It does that, all that for us. You see how that's so much quicker? Okay, cool. What's the mode? Look at the mode at number 8. There's not it on the calculator, so you gotta look. What happens most frequent? 11? 11 happens twice? What else happens twice? And what else? Oh, we just had more than 2. No mode. Okay, moving on. I am asking you the range. Isn't that the highest minus the smallest? The max minus the min. So what's my max? So I'm showing my work. 32 minus 2. So this is ranging over 30 units. It's spread out over 30 units, right? Okay. What's our inner quartile range? Isn't that Q3 minus Q1? Well, there it is. Type Q3 is, and then Q1, and that is 9. So our inner quartile range, and towards the center more, it's spread out over 9 units. Okay, cool. Now, a box and whisker plot is just a way of showing the spread. The spread, not the measures of central tendency, but the spread. So let me just show you how a box and whisker plot looks. So you'll have your number line. A box and whisker plot just shows the spread of the data. So in the start of your box is Q1, the Q2 will be the middle line in your box, and the end of your box is Q3, so your medians. Then all you do is stretch your whisker to your minimum, stretch your whisker to your maximum value. So it's describing spread. Does everybody see? Showing spread, because these are medians, and so it's showing how spread out it is and whatnot. Okay, so do you see how right here we know it's about, this is 75, correct? So our median is about 73-ish. It's about 61-ish, Q1. This is about, okay, so you can do it on a number line, or I'm going to let you kind of just be more sloppy. So let me show you. If I was to do a box and whisker plot for this, I'll let you be sloppy. I won't make you draw a number line and draw it to scale. So understand, when we draw ours, it won't be drawn to scale. It won't be spread out correctly, but I don't really care that much. So we would draw our box, we would draw our line. What is in the middle line? Our overall median, which is 6.5. So you'll just label it. That's Q2. Q1 goes here. What's Q1? 3. This is Q3, which is 10. And then our max, our whisker stretches to 12, and our min stretches to 2. Min, max. So I'm not making you draw on a number line because I'm trying to be quick. Could you draw it on a number line? Yeah, just put it in the right spot, right? You get what I mean by a number line. If I have it labeled from 1 to 15, could you plot it right? Okay, cool. So let's do this one, number 8. Draw our box and whisker plot. So we didn't need this. We didn't need mean, median, or mode to draw our box or whisker plot. I was just helping you see how you could use it, how you could use the calculator. So you draw your box. What was our median? 10.5. What was our Q1? 6. Our Q2 was? And then our maximum value is clear out to 32, and our min value is 2. Cool. That's it. Then, I mean, for your sake to remember what it is for the test, I would label it. So if you need to refer back to it, you know why you put those. Min, Q1, Q2, Q3, and max. I would just write that above it. Easy, right? So think about it. The closer my box and whisker plot is together, all this stuff, the more smushed in it is, the less spread out it is. True? Think about this. My range, the bigger it is, the more spread out the data is. Correct. Okay, cool. So what I want you to do is problem the whole front page. Do the whole front page, and I'm going to leave up this as an example. Yes. I did. My mouse is stuck. It won't let me pause. What is going on? Okay, last thing is that we have to learn is the word percentile, and it really is cool because all of you took the ACT and you were all given what percentile you fill out. So this explanation confuses people, so I'm just going to give you an example straight away, so it makes sense. So percentile is a ranking. It gives you a ranking. So, for example, when you apply to college, I remember when I applied to Snow College and all my other colleges that I applied to, they wanted to know, at Richfield High School, of graduating class 2009, where did I fall amongst the rest of my peers? Because that gives them more meaning. Yeah, your GPA is good, but I don't know, you know what I mean? So they wanted to know where I ranked compared to everybody else. So I had to go and find out what percentile I fell at. So for example, let's say that Bridge drew here. You guys all are in his graduating class, and he wants to know what percentile his GPA is at. So if his GPA is at the 90th percentile, what that means is 90% of the students have a lower GPA than him. If he's at the 90th percentile, 90% of students have a lower GPA than him or the same as him. So that means he's really high up there, right? Only 10% of his graduating class is higher than him. Does that make sense? So if on the last test I said to you, hey, yeah, you scored 72, I'm giving you examples, but you scored in the 80th percentile. That means, yeah, your score 72% didn't seem that good, but you scored 80% higher than 80% of people. You shouldn't probably feel that bad. Does that make sense? So it gives meaning. It's a ranking. So everybody, look at these. So look up here. On your ACT, I'm going to pull out your ACT scores, those ACT scores up, and you can look and see what percentile you follow. So everybody, here are the scores. Here are the scores of the last test of 20 of my students, okay? 20 students. You have to have them. Now, it's a ranking, so everybody listen. If we're talking ranking, you do have to have it ordered from lowest to highest, worst to best. Does everybody understand? So that is the lowest to highest scores. It has to be in order. Now, here are 20 student scores. The lowest score was 41 up to 100. So if I said to you, what score is at the 65th percentile? What score is within the 65th percentile? It has nothing to do with these values. We take the total. We have it ranked from worst to best. So we would take 20 and we would times it by 0.65, which is 65%, correct? So how many values in do we have to go to get to the 65th percentile? 20 times 0.65 is 13. So the 13th score is the 65th percentile. In 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So at the score of 82, 65% of students scored at an 82 or lower than 82. So aren't they a little bit above half of the class? Isn't 50% half of the class? So they shouldn't feel super good, but not super bad for getting an 82%. Does that make sense? Okay, cool. So now here, once again, let's say what I said to you. You got us on some, any of you take the LSAT exam, if any of you decide to go to law school, you will be given a ranking, and that's hugely looked at for law schools. They look at your ranking hugely. So let's say you scored on 90th percentile on the LSAT exam, you're going to have Harvard after you. You're going to have BYU offering you full tuition scholarships to join their law school. In fact, a lot of them, you know right away, I have to score within the 80th percentile to even get accepted. You know what I mean? Okay. So if I said to you, you scored 67 out of 90, and you go home and cry yourself to sleep, and then you come the next day, because that's not that good, and you come the next day and I say, congratulations, you scored in the 90th percentile. 90% of students scored below you, so you shouldn't have felt that bad. Does that make sense? So it gives meaning to your score. Okay, here are those same 20 scores. Let's see where you fell. So let's see. If I asked you, what's the 55th percentile? So you would take 20, the total, and times it by 0.55. It's ordered from worst to best. So how many in do I have to go? 11. So that's 7, 8, 9, 10, 11. If you got 79 on the test, 55% of students scored at you or below you. So that means 50 did better, pretty much. 50 did worse, pretty much, right? You're right in the middle. Okay, yes. The total number of scores that we're ranking from worst to best. So now look, let's find the 95th percentile. 20 times 0.95. 19. Wasn't there 20 total? So this 98 was the 95th percentile. So look how interesting that is. We would only, even though that's the second best score, it still is only appropriate to say 95% of the students scored at you or below you. That's really good. But do you see how it's kind of interesting because only one person actually scored better? Okay, cool. Now, you have to be able to go backwards, which is really hard for people. If I said to you, let's say you wanted to know what percentile you fell at. So what you would do is you would say, how many total students are there? 20. These are scores ordered in from least to best score. What score did you get? Well, let's say you got 88%. on the test you just took? What percentile did you fall in? So that you know where you rank amongst your peers. So what would we do? What do we count in? Wasn't that the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Wasn't that the 14th best score? The 14th best out of 20. So what percent is that? 0.70, isn't it? So that means you fell within the 70th percentile. 70% of students fell at or below you. Does that make sense? Okay. So what I want you to do is finish up 12-1, and that is the homework. So Dallin, since you got a really good math score on the ACT, do you mind telling us your score on the math portion of the ACT? Okay, 27. So let's look and see what percentile he fell in. He's in the 88th percentile. That's being good. 88% of students who take the math portion of the ACT get lower than him. Okay? Okay. So 24, not too bad. 73% of students score at or below you. Oh, it is?